My name is Gosia Zabaj. I work at the Goethe Institute in London, and Dreaming Quantum Futures is part of Living in a Quantum State project, which explores the role of arts and civil society in understanding, discussing, and sometimes also troubling emerging technologies. We do it through an online magazine, we do it through podcasts, and we also do it through a series of events. This is the London event, but we also have had events in Berlin, and we have some events planned in Dublin, Beijing, and San Francisco. I will hand over in just a bit to our brilliant curator, Lucy Rose Sollitt, who will talk a bit more about the concept behind today's evening and the series. But let me just very briefly express my gratitude, first of all, to Somerset House, our long-standing partner, and especially to Emma Hannon, Leonora Manyangadze, Hugh Thomas, Lauren and John, also the Living of a Quantum State project coordinator, Anna, of course, Lucy, today's panelists, and of course to you all, to the audience for coming here tonight, and also for the online audience in the future. I wish you all a lovely evening.
Thanks very much, Gosia. So yeah, it's lovely to see you all here and such a great turnout this evening. So just a really brief few words from me, and then I'll introduce the panelists. So this is the first event in a series of 3 conversations with artists and physicists and theorists, and are exploring quantum thinking. And I'm really delighted to have had the opportunity to work on this with Somerset House, with and everyone, that great team that's been involved, and also with Gosia and with Anna as well. So yeah, thank you for the opportunity. So yeah, just to give a little bit of context on the series, it's inspired by the thinking of physicist and theorist Karen Barad, and her provocation to use the destructive dynamic of quantum physics to expose its radical potential. And in doing so, the idea for the series is to seek out alternative narratives with which to guide the development of quantum technologies, in contrast to the economic and geopolitical ones that often tend to dominate the development of quantum technologies. So we ask, can quantum physics' own insights be used in ways that undermine its own entanglement with these dominant narratives? And what new imaginaries can emerge? And for this evening, we're really delighted to have Suzanne Treister, Alessandra Gnecchi, and Libby Heaney here with us to explore whether other solutions to planetary problems emerge when quantum science, spirituality, art, and the subconscious come together. And the discussion's going to be primarily through the lens of Suzanne's project, Scientific Dreaming, which took place at CERN. And Alessandra was a participant in that project, and some of the work from that project is on display here. So please do have a look around after if you haven't had the chance to look around yet. So without further ado, just to introduce our panelists. So I'm just going to talk through their bios, starting with Susie Treister. Susie has been a pioneer in the new media field from the early 1990s, making work about emerging technologies, developing avatars and fictional worlds. The relationship between new technologies, society, alternative belief systems, and the potential futures of humanity constitutes an ongoing focus of her work. And Alessandra is a theoretical physicist working in the field of high-energy physics and supersymmetry. I don't even understand what that is, but and she's using black holes as a theoretical laboratory to investigate properties of quantum gravity and deepen out our understanding of the universe. And I do understand from Libby that that's really hard. And Libby Heaney is a visual artist with a PhD in quantum physics. She's widely known as the first artist to work directly with quantum computing and art. And her practice uses humour, effect, surrealism, and nonsense to subvert the capitalist appropriation of technology and provide alternatives instead. And Libby has exhibited in the UK and internationally, including solo shows at Light Art Space in Berlin and Art by Gallery in London. So thank you very much, and I'm going to hand over to Libby now.
Okay, thanks, Lucy. So I'll say thank you to the Goethe Institute and Lucy and Somerset House, as well as the panelists here and the audience. So today we're going to dig into what it means to dream up quantum futures. And we're really going to think about advanced physics and art and how we can weave those using dreaming. After all, dreams are the perfect blend of fact and fiction. So my background is in quantum physics. I spent around 12 years working in the field, theoretically, mathematically, working on a phenomena called quantum entanglement. And then around so many years ago, I went back to art school at St. Martin's on my MA Art and Science program, and now I combine the two. So I'm really interested in Susie's practice and the collaboration between Susie and the various scientists. Ali is one of them, to really think about how we can entangle these different knowledge systems to dream up something that's greater than the sum of the parts, and that's what we're going to be listening to today. So the work took place at CERN while Susie was on the residency program there. So I'm going to pass over to Susie to introduce her project, and then we'll hear a little bit about from Ali, and then we'll go into questions.
My earliest work here was already interested in space travel when I was 6. That's the long history. So I'm going to jump straight ahead to the first project I'm going to mention briefly before I get to this one out here is Hexen 2.0. So Hexen 2.0, I started it in 2009, and it was a investigation into the history of cybernetics and how cybernetics cybernetics is difficult to explain in 2 seconds, and I haven't got long. So, but basically, I realized that Web 2.0 functioned in a cybernetic feedback loop, and cybernetics is all about control of human beings. Within this project, I made a tarot deck, and one of the tarot cards was about quantum computing. This one here, I'm just going to show you this one. So this was in 2009 to 11, where it was talking about potential futures then. So I'm going to move quickly on to a later project, Survivor F, where I invented an imaginary character in the future who could actually be possibly the last survivor of the human race, or possibly an artificial intelligence. And I made many works which explored that reality as if they were made in this deep future and sent back to this planet for us to imagine. There's very many works if you click through this later on at home. And then after that, I got a residency at CERN where I met Ali, and where I was asking the scientists at CERN questions about the holographic nature of reality, because I'd had a theory myself that possibly all of art history, right from cave painting through till contemporary art, was an attempt to describe the holographic nature of reality, which had been intuited possibly by artists since the beginning, but which had taken scientists a lot longer to theorize. And that project took the form of interviews with the scientists, which the recordings of which were played during the video projection. The video projection was, it should be up in this window here. You can just see this little bit here. This was about 25,000 images I collected from art history, from cave painting through all of global history until now. And I fast-forwarded them at 25 images a second, emulating the loop of the Large Hadron Collider, which accelerates particles in order to test them. I was accelerating art history in order to test it for my theory. So that's how I met Ali. One of the recordings is by her. Then I carried on my interest in black holes. I invented another character called the Escapist, black hole space-time, who possibly is an indeterminate character who exists in time and space, possibly lives inside a black hole, and created all kinds of other images. So this is like a comic book strip of the Escapist and his adventures. He's kind of a he in my mind. These are paintings, these are other drawings. Each one leads to a whole series of works, and this one in particular I went back to CERN to do this part of the project, because while I was talking to one of the scientists, he talked about extraterrestrial life forms and how it was almost inevitable that there were other beings in outer space, in the universe, in terms of the probability of it, and based on how many planets there are. And so I asked him to do an image of what he might imagine an extraterrestrial to be from his perspective, and this is what he did. And so I decided to ask a whole bunch of the others to imagine from their point of view what might constitute a being from another planet. And these are all from their imagination, all the examples that they came up with. So moving right along, I think I'll move straight along now to, well, maybe we'll go into outer space. This was a project I did with a collaboration with a group of people. We formed this Museum of Black Hole Space-Time Collective, and we traveled through space to the Museum of Black Hole Space-Time, which exists 40 billion light years away from Earth. And when we got there, we did drawings of what we saw inside the museum. So, for example, this was the first one. This was us sitting around having a kind of teleportation seance. And these are all the images we came up with of what existed inside that museum. So to fast forward now to the project I did recently. So I wasn't actually on a residency at CERN this time. I was on a residency at Lebec on Lake Geneva. And it gave me the opportunity to go back to CERN and do this project, which I'd had the idea for several years previously, but hadn't been able to do because of COVID. So this is what happened. So the original idea was to get scientists to write science fiction stories so that basically they could use their knowledge in a way that was differently from a science fiction writer who maybe didn't have that knowledge. They used their knowledge to possibly come up with ideas of a more positive future that might be feasible, that we could actually work with. And so I didn't want to tell them what it was at the beginning. So how it worked is I had individual sessions with them, one at a time, and we sat there. I had a piece of A3 paper, they had a piece of A3 paper, and I kind of tried to get them to relax, and I said, we're just going to be drawing certain things on this paper. You're going to draw them on yours. I'm going to draw the same thing on mine. So would you like to first start off just thinking of 4 dates, and possibly dates in the future, and write them in the 4 corners? And then let's take one of these diagrams. Hold on. Let's take one of these diagrams. So so then I'd say, I draw 4 circles in the middle and think of, just make up a name, any name, not necessarily someone you know, but just a name, imaginary name. And that was the point where they got, like, what do you mean? What name? What kind of name? And they were stressed. And then eventually I said, look, just like Joe Bloggs, any name, just think of any name. It doesn't matter. Just write it. So they wrote down a name. And then we came to the second one. They easily wrote another name, and then a third name and a fourth name. And they became kind of relaxed. And then I said, now what we're going to do is we're going to do little ovals on either side of each character. And I'd like you to think about that character's occupation. So, just take your time, think about what they might do and maybe their life. And so we were going to write down their occupation in this area. And then maybe how old do you think they are? Anything else about them? Some of them wrote down more, some of them wrote down less. And then I said, so now we're going to go up above those characters. I want you to do a large oval, and I want you to think about what might be, really stretch your mind. What might be a really radical breakthrough in terms of your knowledge, and what might be a really radical breakthrough that might have a huge impact on the world, on the planet. And at this point, they were all really like in a zone where they had these characters where they were like in a kind of imaginary zone and very relaxed. And so sometimes they'd come up with something, and I'd go, okay, but that's kind of happening now, or that maybe isn't going to have an impact or something, but let's think a bit further, think a bit more, what if this, what if that? We talked it through, and they basically pushed themselves to the edge of what they could imagine, and then they wrote it down. And then I said, well, now we're going to go down here, and we're going to do 4 more circles, and we're going to think now. So this character here, so this is what they do. They're a florist or whatever, and they've had a hard day work. They go to sleep in the morning. They wake up with a start, and they remember their dream. And I'd like you to tell me what that dream was. And so quite happily, they told me their dream. I said, it can be a dream you yourself have had or not. So then we wrote down the 4 dreams. Then we went up to the top, and I said, and now I'd like you to look at these scientific breakthroughs and think about what the outcomes might be for each. And obviously the positive outcomes, and there's obviously going to be some risks, and so maybe you want to think about some not so positive outcomes so that you can write those down too. So they wrote those. And then I said, and now we're going to go down below the dreams, and I said, do 4 more circles. And in those circles, I'd like you to write the outcomes for those individual characters of your scientific breakthrough. And then, so this diagram, I'm going to go to a different one. Then I said, we're almost done. So now we're going to just write the word events and the word locations in a spare piece of the paper. And I'd just like you to write down 4 events and 4 locations. And so we finished. And then each time I'd say at the end, so what do you think this has been about? And they'd say, I don't know, you just want to know something about this, or some art project you're doing. Well, we have no idea. And I'd say, well, look at your piece of paper. What you're looking at is the plot diagram for the science fiction short story that you're going to write. And each time they go, oh. And they realize it wasn't about me, it was about them. And it was about them actually doing something different. And in fact, practically all of them were very excited and thrilled. They said, wow, we can do this over our summer holiday. This is really thrilling. And this has been really great because it's, I've been so stressed, and now I've got this whole other thing I can do. And they were, in general, really happy about it. This is one of them. Maybe, I don't know how happy he was. But there was a couple of guys who weren't happy, and because they hadn't taken it seriously, and when they looked at their plot diagram, they realized it was all about them, and they hadn't taken it seriously, and it wasn't very good. And those are the 2 that, well, one of them, that was the case for one of them, he didn't do it, so that's all right. So we haven't got his story. And then these drawings were where I extrapolated from the categories that were in each of the plot diagrams. So you've got, in this one, for example, you have all the scientific breakthroughs together, and you can identify them all in one drawing. And then here we have the beginning of the stories, because they're still being edited. So what I've done here is put some excerpts from each of them so far. And Ali is still working on hers because she's switched jobs, so she's been really, really super busy. But hers has been started, and hers will be going in this gap here.
Thank you very much, Suzanne. It's always fascinating to hear about your work, even if I know a little bit of them. Yes, as for the introduction, I'm a theoretical physicist, and I'm a high-energy theoretical physicist. What does it mean? It means that in my line of research, we try to make sense of all the fundamental forces, all the interactions in the universe in a unified description. And for all the forces that keep together atoms, nuclei, the forces responsible for nuclear interactions, we have pretty good knowledge about them. We can control them. They've been tested very well. They are constantly under test at big accelerator experiments. There's one running now at CERN, the Large Hadron Collider. That's where I met Suzanne, and that's where we worked together, started working together. But there's another force, which is gravity. And, and gravity, we don't really understand that well. Well, general relativity works very, very well in our universe, but we don't understand the quantum description of gravity. Once we try to get into the quantum realm, gravity is elusive. We cannot describe it in the ways we usually do. And actually, what happened, what we know so far, is that when you go fully in the quantum regime, gravity becomes holographic. That's part of the holographic description that Suzanne investigated at CERN. And what it means is that whatever happens inside our universe actually can be completely captured by a description that lives at the boundary of our universe. And to understand the quantum properties of gravity, one of the greatest tools that scientists have at hand are black holes. Black holes are our, as said in the introduction, is really our theoretical laboratory. We can think about and ask questions about what are black holes at the quantum level. And then we are taken into these deep investigations of fundamental properties of gravity. And thanks to Stephen Hawking's work, and I'm glad I'm in London to mention his work, we know that black holes are somehow interesting objects that at the quantum level do not separate anymore the space-time between the interior and the exterior in a way that the two of them cannot communicate. At the quantum level, there is some connection between the interior and the exterior. There's some radiation that gets out of the black hole once we go in the quantum regime, and this evaporation contains entanglement. It's an entanglement between the interior and the exterior of the black hole, and we are trying in our research to figure out the details of this connection, this entanglement. And to me, it's interesting because this entanglement is what carries the information inside of the that was inside of the black hole. And so we're back talking about quantum information, and quantum information is the subject of quantum technologies, and it will be understood better in the future. And I think it's going to be a protagonist also for tonight. So I'm very, very happy to be here and looking forward to the rest of the discussion.
Thank you. Wow, there's so much there already. I'm really excited to jump in. One of the things I really like about your work, Suzanne, in general, is how you're changing constantly in the different projects we've heard about, the viewpoint of where you're coming from teleportation, from non-humans, from zooming into things, zooming out of things. And this essentially is what Alessandra is doing as well. You're really looking at kind of the quantum level, which is the microscopic, but then using these huge gravitational forces within the universe to do that. So hopefully we can start entangling these things a bit more throughout this talk. So Suzanne, your practice takes different ways of knowing the world, really from the scientific, obviously the artistic, but also the literary, the spiritual, and the paranormal, among others. It's really wide-ranging, and I think that's why it's so exciting. And I'm really fascinated about the background component of your project, which we haven't heard about yet. And it's interesting how you called it on your website a background component. This is your term. And this is a component with the pressed flowers. So if you had a chance to look at some of the images before you came in, you would have noticed that there's some books there, which were, well, I'll let Suzanne explain this, but I'm really fascinated to know why this was important to present as the background to the Scientific Dreaming Project, particularly in relation to knowledge systems and the scientific method.
Okay, thanks for that question. Because actually it happened quite intuitively, that component. And so I've actually, because there's a lot of these the questions we're going to be talking about are going to involve a lot of information from the stories, and I'm going to need to quote from things. For the first time in my life, I've actually made notes. So normally I say the first thing that comes into my head, but since I'm dealing with other people's work here, the scientists' work, it's not appropriate for me to do that. So as I said, I was able to do this project when I was at this residency in Labec, which was on Lake Geneva, an hour away from CERN. And when I went on that residency, I took with me in particular, this one book called Dream Symbols of the Individual Process, Notes of C.G. Jung's Seminars on Wolfgang Pauli's Dreams, which intertwines the arts and the sciences and the sciences through a long-term analysis that Jung carried out with Wolfgang Pauli, who had very many problems and went to him for help. And so Jung interpreted his dreams over I think maybe a 30-year period. And so during my residency, I'd planned to again visit the Pauli Library at CERN and also Jung's house on Lake Zurich while I was working on this CERN project. So while I was at Labec, it was a beautiful environment, and we went walking a lot in the Alpine meadows, and I started collecting wildflowers there. And they have some, they're known for their wildflowers. They have all the narcissus fields. They have flowers which probably don't exist anywhere else. Maybe some of them are quite rare. And I decided to collect samples of those flowers and take them back and press them. And so the one big book that I had in the studio that would be useful to pressing flowers was this book on Jung and Pauli's on Pauli's dreams. And so and because this book has that kind of duality between psychoanalysis and science, by putting those flowers into it, it kind of added like a third element of kind of natural beauty, of something which was kind of real in a different sense, to break up that duality, I guess. And because once I started doing that, I decided I needed to go to CERN and find some wildflowers in CERN, which was a hard task. But I did, and I pressed some of those as well in the book, so that there was that relationship as well of the two. So it mirrored the whole content of the book within the flowers in the book. So and then I guess what happened then is that actually gave me the inspiration. Using that book in that way and bringing that book gave me the inspiration to then try and use scientists' dreams in the science fiction writing project as another way of unlocking their subconscious minds. And so it's kind of convoluted. That's the best explanation I can give, I think.
But I think that's great, because it's really like embracing the coincidence and chance, which is so fundamental to quantum physics. In quantum physics, you have this wave function where different possibilities can exist at once. But when something observes this wave function, it collapses randomly. So I see your process almost like using this randomness within your daily life, these coincidences, is kind of almost embracing a quantum way of making art as well. It was really interesting. And flowers as well, as a mode, almost a mode of entanglement. So you spoke about how the flowers kind of broke down this duality in the book, but then you also picked them at CERN as well. So there's these sort of almost like non-local connections occurring between how you're working. So I think it's absolutely, that's how I read it. I think it's fascinating.
That's very kind of you.
But the work is meant to be read however we want, right? So, so I'm going to come over to Ali now. And obviously you had your consciousness unpicked, or how do you call it, unpacked, or by Suzanne in the workshops. And I want to ask you how challenging it was to start to, because we've already heard a story from Suzanne when she presented her talk about how some of the scientists reacted to this process. And I know from my own history when I was a scientist, sometimes it's so hard to get out of that like mindset of everything has to be right, you know. And it's taken, for me personally, it's taken me years to kind of break that down and become more fluid. So how was it to be have your mind tapped? And just finally, how you were embracing intuition, maybe embodied knowledge, the irrational, the spiritual, and/or the paranormal.
Thanks for the question. It was hard. I have to say, Suzanne has always a very effective approach to dealing with scientists. She knows how to push them in the right direction, but we needed to be pushed because it's not easy for a scientist to imagine something that is outside of the logical view of things. That's what we do. We try to find a structure, we try to find a law, we try to follow it, and Suzanne was really taking us away from it. And scientists don't like when they get into an environment and they don't know the rules, they don't know what to do. And it was, I think, very important to find myself in a situation where I didn't know how to handle the story. I didn't know how to handle my own imagination. I'm used at imagining things that can happen. I'm used at imagining things that make sense in my reality. And so approaching a different reality was very hard.
We need some chaos. You need some sort of push to embrace the sort of chaos of moving across different knowledge systems, because it was interesting how you said, we're used to thinking about the logical view of things, but actually there's multiple. When we move into a quantum way of thinking, there's multiple ways of viewing things, and they can all be quite logical. They have their own intrinsic logic. And I think what I'm trying to dig out, feel free to respond in a second, but what I'm trying to dig out is how we can bring different bodies together through practices like Suzanne's to embrace something that's more quantum.
Yeah, I think that it's important to realize that all these different views have different purposes. The scientists have a view that brings them to understand the laws of nature, to then possibly develop new technologies. And that's their reality. But there's different purposes, and most of us have the purpose of enjoying their life. And that brings a completely different set of rules, or just understanding our senses, our perception, investigate our experiences.
So I feel like Suzanne, your aim, correct me if I'm wrong, with a residency was to dream up positive futures in terms of solutions to the planetary problems that we face. In what sort of, we've seen a lot of the sort of the diagrams, what do you call them out there? What's it? Plot diagrams, yeah. And so in which ones, how would you judge whether a plot diagram was successful or not in terms of the dreaming of futures, but also as Moses storytelling as well?
How would they be? I wasn't necessarily thinking of them. I don't know what. When you say successful as
exactly what
as fiction or successful as thinking up positive
I'm trying
futures?
to think of what your
So in terms of the positive future, I mean, the thing is, I think a lot of them are quite resonant in different ways. Mm-hmm. So there's one of them, Claire Adams. She had this amazing historical speculative fantasy where the French president, Francois Mitterrand, invents, just through conversation, invents this giant vacuum cleaner which extracts all the heat and everything from the atmosphere and turns it into usable energy. And this would be within his reign. I mean, this woman was a very literary woman. She was quoting Umberto Eco. One of her characters, I think, was based on Umberto Eco. Anyway, so that was one thing. And then I'm going to read you a quote here. Then the story by Michael Doser. We were taken through the end of the climate crisis of the 21st century, through the anti-technological 21st century to the 23rd century, where science returned, but there was a perfect balance of new technologies and Paleolithic models of resource allocation. And part of his story goes, dealing with the hydro wars and the polydemics revitalized science, but accompanied by a deeper understanding than that which led to the stop and go, even if increasingly concerted, tackling of the causes of climate change in the mid-21st century, or the wholesale rejection of technology in the 22nd. This new scientific renaissance led, in fact, to a renewed awareness and understanding of the Paleolithic balance of innovation with societal needs and the availability of scarce resources, and thus a system of resource allocation and reuse rules that were technologically implemented in a simple, transparent, and to a large extent egalitarian manner, and consequently perceived as just. And then he talks about, and he goes on, because there's a thread through his story about it happens in Tokyo, a Japanese writer who's writing a kind of comic book simultaneously about, because her partner is a co-researcher on the technological side. And he goes on, some art historians even trace a direct line from the current highly popular paleotech synverses fad, so so characteristic of the new dark age, to the visions Takeshi wove into the last third of her novel, art not only predicting but actually shaping the future. So I think that's a relevant comment for tonight. And then BK, who's under a theorist, a theoretical particle physicist who goes under the name BK. We're taken through several phases of the evolution of machine intelligences into the deep future, where there are new ideas of consciousness and where the machine intelligences are perpetually seeking enlightenment. And so this is a quote from halfway through his story, which goes, This has led to a proliferation of hyperconscious machines of an enormously rich variety. Each one carried its own universe within itself, an evolving world of its own. Clearly a spiritual one, since almost nothing resembled the physical world anymore. And then from his final paragraph, on the other hand, as humans had already suspected, there was an intrinsic relation between quantum information and the physical geometry of space-time, the latter being, in a sense, emergent from the former. Now that computational processes had intensified so much, the density of quantum bits foreseeably hitting fundamental boundaries, a controlled influence of cognitive processes on physical space-time started to appear on the horizon. Macroscopic entanglements, realizing wormholes just generated by conscious decisions, appeared possible in the distant future. Very distant indeed, but there were many more billions of years of evolution up ahead. Entity 1 was aware of that, but there was no way to get anywhere near it with its electronic hardware. It was time to stop and merge with something better.
I love these. I could just listen to you read these stories.
Anyway, so I want to say, so in terms of the outcomes of a positive future, there were several recurrent themes. Apart from these were interesting stories, but there were several recurrent themes which involved advances in quantum computing, and they involved advances in quantum computing and also the identification of dark matter and dark energy. Those were the main themes, and I could go on and talk about them.
So,
shall I?
Yeah, I just feel like, as well, just to comment, the scientists are kind of solving their own research problems in the future, perhaps. No, okay.
Yes,
it's like, oh, and then there's macroscopic entanglements, and these were. So it's almost like they've prophesized what they want to happen in their own research.
Because I think all my relationships with a lot of my relationships with scientists at CERN, I realized that, well, a lot of their experiments, there was a lot of the experimentalists, perhaps, there was a lot of waiting around. Like one guy had been sitting there 40 years waiting for a blip on a small screen, which was going to be dark matter. And he was, and he could. His big chance was, I think it was the 17th of December, when from the cosmic center there was a ray that went behind the sun and converged behind the sun. And then at that moment, on the 17th of December every year, there was a greater chance of identifying dark matter.
It's like a performance artwork,
yes. So the thing is, some of these people have a lot of time to think. Yeah. And so they extrapolate endlessly. And he told me all kinds of things which I wasn't allowed to repeat, which I have not repeated. And he's not doing this project, so don't think you're going to find them in there. Because he was concerned that you're not allowed to extrapolate too much at CERN because you have to have a sense of responsibility. You can't let the public run away with all these crazy things because there's all these crazies out there that start thinking stupid things. So the CERN's under a lot of surveillance and attack from a lot of strange people in the world. And I became a victim of that myself when I did a residency there. They told me that I did the Tarot Hexagon project at CERN, even though I'd done it 6 years previously, before I ever entered CERN. So that's how they think. So we have to be careful. But I realized that there's massive scope for thinking up all kinds of ideas, and this project, in a way, would allow them to come up with them, actually to articulate some of them, and maybe in a positive way where they could. Fiction is a forum for ideas in that sense, because we know they're fiction, but you can still work with them because they connect to reality as well, whatever that is in this context,
Yeah, absolutely. I mean, scientists are very guarded about when they speculate in case it is misinterpreted by the media, and I guess the eyes are on places like CERN because they're so globally famous. I'm going to invite you, you can of course comment on this as well, but I'd also like to hear about your plot diagram afterwards. Yeah.
Yes, very happily. I just wanted to add that I think there is also a little bit of shame in speculating when you're a scientist, because somehow you feel like you have to be bound to logical description. So if you I don't know, if you dare to imagine something that makes no sense from your physics point of view, it feels like you're a bit ashamed, like of being judged, and that's like a bit nonsense thinking about it, but I guess that from the professional point of view, it's inevitable. And that's also an obstacle to address when trying to get your mind out of the known.
Yeah, I feel like when I was a scientist, it was like, because I didn't have a permanent position, and you have to be taken very seriously to get a permanent position at a university or an institution. So you're being very careful what you say in case they're like, well, you said this, so you're not a serious scientist.
But instead, I mean, the questions, right? Any kind of questions. That's how we progress. We ask all the possible questions. So we are allowed to ask a question that makes no sense. It's just that we have to figure out if it makes sense or no. And so, yeah, I think I like questions no matter what. Explorations. That's why probably I really like working with Suzanne, because she makes me do that.
Yeah. I'm sure she did. So, okay, would you tell us about your plot diagram, please?
Yes, my diagram, when Suzanne mentioned like that at the end of it, sorry for starting by the end, the scientists were amazed that actually the whole project was about them, not about Suzanne. We had to write a story. It was well, not funny, but like a mixture of excitement and fear. But this diagram was our canvas, and it was not easy to come up with different concepts. Like it was easy at first to because you made us start from the scientific breakthrough related to quantum technologies, and that was easing us into this work, this exercise. And then we had to connect these to our stories. And again, we had no constraint. And again, that's very hard for a scientist to be able to say anything. We usually start from something precise, and then we connect the next thing, and then we know what the next thing can be, and we know mostly what cannot be. It was going back and forth between, I don't know, dreams about our research, as you were saying. I think all of us picked a little bit from our work, but that connecting it with an outcome that maybe we hoped would happen in the future, but we're not allowed to say it, because maybe it's gonna happen in 20 million years. So we cannot really say anything about it. But I don't know, I guess it was very nice to have this white space that kept being created. And that was, I don't know. At the end of it, I think all of us were very engaged. All of us made it to the end of the diagram. It was filled with ideas. And I think it was very good that it was not finished there. At the end of it, we eventually got out of our structured mind, and we had the chance with the stories to bring it, to actually collect all these ideas and made it flow in a sort of story.
How is the process of taking the plot diagram and translating it over into the story?
I think it opens even more possibilities. The connection between the dream and the scientific breakthrough, again, offers a lot of possibilities for our minds, for our discoveries. And
can you tell us a bit about your story, the narrative?
Yes, so my characters are a man and a woman, and a dog and a humanoid, and they all have the characteristic of probably trying to find something in their life. They've not arrived yet at being completely fulfilled. And it's also thank you to quantum technologies and a breakthrough in the future that they will be able to find a sort of life that they are happy with. And in particular, with quantum computation, one of them will be able to perform cancer research much faster and decide to finally go back to study philosophy, which was one of her main interests, but she couldn't do it. Another was trying to reach the Indian Ocean, and thanks to quantum computing, the distribution of resources in the world was such that he could finally settle down without having to travel around the world, and the dog ends up entangled with a black hole in an attempt to extract information from the black hole, but in his continuous travel, trying to find the right town, the right kind of interactions, in this entanglement with the black hole, he finally finds himself not alone. So yes, that's where I am, and I probably have to think better where I'm going to finish it. We'll see.
That's wonderful. I love the idea of a dog entangled to a black hole, and I'm really excited to hear what happens next. You've left the story on a cliffhanger, so it's always a good technique. So, hang on, where am I? So I'm interested in the languages, of course, and the plot diagrams seem to be a bridging technique that was able to go from the artistic point of view. You know, the plot may look like comic books, storyboards, Jeremy Deller's Acid House to brass bands, this mapping of this non-linear reality, yet the plot diagrams to me look a little bit like a blackboard of equations, a set of entangled relations. So in order to dream positive futures, what other bridges and languages might we need, especially if we're to include non-human voices as well? So not just between the science and the arts, but generally, how can we create spaces where different systems of knowledge are really able to flourish together, like the flowers in your books?
I'm slightly concerned because I missed out telling about all the other possible positive outcomes, which were really relevant.
I would love to hear more.
Can I just do those first?
Of course you can, yeah.
Sorry. So I wanted to talk about the all the ideas that they were coming up with for breakthroughs in that would could happen if dark matter and dark energy were identified, which obviously they haven't been. That's a very big stumbling block. So the main hope was that they would solve the energy crisis, that they would be able to provide a limitless clean energy resource, which would result in general improvement of the environment. And then there was another thread from the dark matter, because apparently it could enable us to learn how to actually travel in the universe and communicate with unknown parts of the universe and other civilizations, even 1 billion years away. And I'm hoping Alessandra is going to explain how this could happen, because I didn't totally understand how it could happen. And so a lot of scientists reckoned it could help understand the root of our physical selves and develop more profound understandings in general. And one scientist even idealistically proposed that encountering other beings in the cosmos might make humanity more loving and tolerant. And a quote from her plot diagram is, "If we manage to learn more about the universe and other possible cultures and other forms of living, maybe humanity could finally change and become better and stop being violent." So there's a sense that in a lot of the scientists that they're quite idealistic. That's kind of interesting. And then in terms of the advances in quantum computing, so many of the stories suggested that development of fault-tolerant quantum computing could bring many positive but also risky changes. And so, for example, that it could solve the optimization problem of distributing resources to everyone in the world, making life sustainable. That was one of Alessandra's. It would speed up the development of artificial intelligence and machine learning, and that quantum computing fusion reactors could improve astrophysics and climate predictions, and that it would increase the speed of this is in terms of the most relevant to a lot of people, that it would increase the speed of pharmacological research and drug development and find cures for cancer and other diseases. And then there's this idea that it could increase lifespans to maybe 120 or 130 years, which brings its own issues. And then, in tandem with dark matter's potential enablement of traveling and communicating with the universe, these communications would be codified in a quantum form. And then one scientist talked about the development of room temperature superconductivity, which would mean we could transport electricity for thousands of kilometers without dispersion. So, for example, electricity from a solar energy plant in the Sahara could be transported to colder regions, which would allow us to use fewer natural resources and lower waste to preserve the environment. And obviously there's a lot of potentially negative risks and things involved in a lot of these developments. Increased potential for social control, greater divides between rich and poor, and dangers of who uses the technology, of course, which is always the case. So those were the main potential outcomes, I think, that I've covered there.
There's a lot there. Are you tempted to, when the scientists are being maybe more idealistic, are you tempted to push back and invite them to think more about the risks, or do you?
I did.
You do, yeah.
I recorded all the sessions that we had. They became a little bit like psychotherapy sessions, but not in the way where I'm silent. They were very interactive. So I would say, had you thought that, there was some ideas which were quite strangely optimistically naive, even. Like one person had the idea that there could be a technology to grant humans every wish. And we all know where that leads.
Exactly. I feel like a longer term engagement between scientists and people in the humanities, so that they're able to think more widely outside their field through some of the ethical questions, would be really beneficial. But that's me being idealistic as well. So
I don't think it's idealistic, because I think that there's so much going on now, which is to do with there's so much interdisciplinarity going on. And there's this thing called nexus thinking. There's a whole bunch of things which are happening where fields are coming to converging.
I hope, I really hope that, but I do definitely still see the massive silos around within the sciences, from my perspective.
Right.
So hopefully more of these interdisciplinary hot soups or whatever will come to fruition. Let's jump,
No, I was just going to add that as a scientist, it's hard to know that you are right in describing the world, but sometimes that's not the point, right? When we talk about society, most of the laws of nature are just in our background. We drive cars, we warm up food in the microwave, but we have other goals in society, and scientists should find a way to communicate their knowledge in a way that it's directly useful to society. So I'm also idealistic, but I think there is ground for this conversation.
I definitely, and where art is a bridge between these things as well, that can allow these conversations like we're doing now.
Bringing the concept to the human perspective, right?
Exactly. I'm jumping back to my previous question. I was thinking about how the plots are these bridges between the arts and the sciences, because the plot diagram is something that both disciplines really understand and can really work with in an intuitive level. So what other languages might we dream up that enables this type of collaboration to happen?
What do you think?
I think it's ongoing research, finding the right discussion, but I think that moving the conversation towards more interactions, I think this event is fantastic in that sense. Will bring science out of its cage of being just dictating rules. And I think that more collaborations with artists, more collaborations with a perspective that's more human than mathematical is probably on the right road.
I was thinking the other day about having I talked to someone about this, and that maybe like book clubs might be an interesting idea at in these scientific research places, because I think that I could tell that out of all the scientists I've met, the ones who've read more literature seem to have a broader understanding of a bigger perspective.
I think that's a great idea. I think literature's so accessible for everyone around the world as well. And also films, I suppose, are similar in that sense. I'm going to take that as an opportunity to open up to questions from the audiences. Thank you so much for responding to my questions so far. Does anyone have any questions related to what Suzanne and Ali have spoken about today?
I was wondering in your conversations with scientists whether anyone came up with unexpected social or political innovations as a result of quantum science, rather than things that were rooted in kind of more material, like what we expect of material science.
Well, I mean, the Michael Dosa story, where he talks about different social systems through the 21st, 22nd, 23rd century, the movements against technology, a return to the kind of anarcho-primitivist idea of returning to Paleolithic systems. He did kind of touch on those, really. And then BK, he did in the sense, but they were machine intelligence societies. Humans were very quickly superseded in his 4 stages of evolution. There seemed to be a very early form. So all their social setups are almost like irrelevant because there seem to be just lots and lots of people with similar qualities. Why did we need so many of them in the first place? They were basically phased out because they weren't useful.
Ali, did you come up with any social, political sort of future suggestions in your story so far? Or
I think the redistribution of resources, thanks to a quantum computer that could, at any moment, decide what goods go here and there, sort of wanted to have an impact on society. There was like, how do we create a world we can all live in with the resources we have? So instead of creating a breakthrough that would just, in a billion years, create a new intelligence, it was more like towards an applied sustainability. So maybe that was the society impact I envisioned.
I mean, for me, imagine if a society was to fully think, like, instead of thinking through these binaries, we live in a Newtonian world, and quantum physics has such a radical potential at its heart with quantum superposition, where something can be in multiple places at the same time, or entanglements, which we've heard of. If you were to imagine politics through the lens of quantum physics or through entanglements or society, I think we could really think of other alternatives, of ways of living, and so on.
I had something about that I didn't say. I wrote earlier. What was it? Okay, I'm just going to have to read this whole thing because I can't see the bit. It was the answer to one of your previous questions. So I was talking about the kind of more holistic systems, and so I've kind of wrote down this notes like, well, in recent years, there seems to be an increase in people talking about interdisciplinarity and convergence and other similar ideas like nexus thinking and working together across various fields. And that's so I've said, so these art science projects are just actually a small part of that. And for a long time, people from various cultures have understood that everything is connected. And more recently, this idea has gained scientific validation and wider acceptance because of it being embedded within quantum theory. And so that means that people in other fields like politics are having to realize that it's not necessarily all about competition, that they're actually working with people and working across fields actually might help. in the end of the day. And yeah, so I hope more and more people from all fields will come to understand the importance of thinking more holistically and collaboratively to solve the world's problems for a better future. And so from politicians to scientists to corporations to artists and thinkers to everyone, and especially when it comes to the implementation of cutting-edge technologies where, for example, we risk going into space and destroying asteroids and even the whole universe. And now listen to this. So one of the CERN scientists posited a risk of working with dark energy, that although it could not interact or damage us because of the different type of matter we are made of, that didn't mean it wouldn't be capable of causing the destruction of the whole universe.
I mean, yeah. So, I think just to touch back on this idea of like indigenous knowledge and non-Western knowledge systems, which obviously you're thinking in terms of shamanism and spiritualities in a lot of your work, has already understood the world in these pluralistic and entangled terms. And it's almost like we in the West are just rediscovering that. And I think that's so important I'm really glad you brought that up there as well. Do we have any other questions?
I was thinking if there is connection or if that can be a link between quantum futures and accessing the subconscious mind. Thanks.
The unconscious mind, you mean? Subconscious. I would think that with our advances in mapping our brain functionalities, if we had a quantum computer that could take any sensor, like electric stimuli and elaborate it live, that would be possible. And it's creating an artificial brain is somehow one of the scientific goals, I think, and quantum computers definitely would help in elaborating this huge amount of data.
You didn't answer the question that I was opening up before, because we got sidetracked, to explain about how one may be able to communicate with the universe and
one of the
and travel through the universe as a result. How would this happen?
It would happen through entanglement, right? You would position different stations around the solar system or the universe, depending how much time one has, that contain entangled system with Earth, and then slowly by collapsing the wave function and resolving the disentanglement, you would be able to communicate instantaneously between, or have an effect instantaneously on these stations around the universe by performing observations on Earth, and that maybe would create a certain event that whose outcome then would make us learn about the atmosphere of a planet or the habitability of the planet.
So when you say communication, you don't really mean having a conversation. You mean a different kind of interaction.
How much am I allowed to be idealistic and to
how could you imagine the conversation happening then? With other civilizations, let's say, from billions of years away.
That would be quantum communications, and through if we could govern completely entangled systems at the macroscopic level, then we would be able to really to see universe and space and time in a completely different way, I think.
100%. One thing that came to my mind, and this is a question for both of you, perhaps the final question tonight, is if our conscious mind is like the 2D surface around the black hole, is it the hologram of something deeper, our subconscious mind? Does that make sense? Is our conscious mind a hologram?
Yes, because it lives in a world where there's gravity, and so there is a holographic description of our minds. Let me use this maybe parallel concept, the black holes store all their information in the boundary, but not only. Bounds tell us that you cannot throw into a region of space-time more information than the one described by the area of a black hole that would fit that region of space-time. So, you know, it's like the black hole is a quantum encoder, a quantum computer. And so this is the ultimate quantum system, I would say, that is that has a fully holographic nature. And I think that this is so interconnected with information that, you know, it's intriguing to think about our brain. Our brain contains information. It contains how we decode our sensorial experience, or even extrasensorial, I think. So, yeah, it's a fascinating question and fascinating concept. And I think that by learning more about what is quantum information, how it behaves, how we can control it, and how it can affect society, we probably will also learn a lot about how we work.
And Suzanne, do you have any final comments before we wrap up about our conscious mind versus subconscious mind in terms of holographic theory?
Well, only that, and in fact, at CERN, I had a lot of problems with people, with scientists, with the word consciousness in the first place. By a PhD student, I was told I was a complete idiot, there was no such thing. By a very senior, brilliant guy, I was told that actually consciousness is part of a triangle where the brain is elsewhere and something else is here. And he's actually done it on my holographic Universe Theory of Art History project. You can see it. And obviously consciousness is something which we still don't understand. So,
okay, let's end on that point. Yeah, I was trying to understand consciousness through that lens. We can leave that for a drink later. Thank you so much, Suzanne and Ali, to the Goethe Institute, to Somerset House, for everyone who came to listen to this talk. Your project is absolutely fascinating, so I'll encourage people to grab a refreshment and to take a look at the plot diagrams and the other diagrams outside.
Thank you.